All right, so today is a day one lesson of radical functions. So our essential question is, how do I graph and transform radical functions?
If you want to be an aerospace engineer someday, you may use transformations of radical functions to adjust for gravitational changes on other planets.
Interesting.
Recall that exponential and log functions are inverse functions. Quadratic and cubic functions have inverses as well. So as we look at the graphs below, they show the inverses of the quadratic parent function and the cubic parent function. Quadratic parent function is in blue. Cubic parent function is in blue.
Got it.
The inverse is in red. So notice the inverse here in red. It's plus or minus root x. That is not a function by the vertical line test.
Yeah, if I draw a line, oh boy, if I draw a line straight down,
yes,
it hits it in two spots, so
right.
It's not a function.
However, if we just focus on the function square root of x, the positive side of it.
Not this bottom side,
ignore that. Yep, but just the top side, then it would be a function. And that is what our focus is going to be today. So maybe, I don't know, in black or blue or green, maybe just show what I'm, like the up part.
Yeah, so we just want, oh boy, this
Yep,
part.
that's the positive. So maybe
And not this part.
Not that part, yep. So the black part that Miss Boyd just highlighted, that would be this, the inverse, but just the positive
just
side.
Just the positive.
Yeah.
Okay. So I'll just write it here.
Yeah, good idea.
f of negative 1 of x equals positive
Yep.
x.
Correct.
Okay.
That's what we're focusing on today.
Great.
Graph each function and identify its domain and range. That's what we're going to do right now.
All right.
And so what I like to do here, yes, we have calculators, but I do want to show you how you can make a table for this kind of graph. So we're going to have an x, and then obviously a y. You can do whatever you want.
Minus
yep.
3, so we see what we're doing.
Yep.
And then our actual
point, right?
Yeah.
Or whatever.
Oh, sure.
Whatever you want. Yep.
Our x and
our y.
f of x.
Or y, yeah, either way, yeah, because y and f of x mean the same thing.
Great.
So I started at 3, and the reason I started at 3 is
because if we plug 3 in, square root of 3 minus 3 is 0.
And you can't plug in anything less than 3
no,
because then you get a negative under a radical.
Okay.
So your point's going to be 3, 0.
Great.
So now let's just go up to 4. X is 4. If you plug in 4,
square root of 4 minus 3 is 1. Square root of 3 is 1.
Square root of 1 is 1.
Or, sorry, square root of 1 is 1.
And so the point is 4. Yep, right. And so maybe put little, because that looks, Then I did 7. So what I tried to do is get nice radicals, right?
Gotcha.
Because I know that 7 minus 3 is 4. Square root of 4. The square root of 4 is 2. So the point is 7, 2. And I did one more actually. 12.
Oh, I'm out of colors.
Oh, well.
I'll do red.
All right, 12. Because the square root of 12 minus 3 is the square root of 9. And the square root of 9 is 3. So the point is 12, 3.
12,
so let's plot these.
All right.
So should we do the colors of the dots?
Yeah,
oh, okay. All right.
1, 2, 3.
Yeah.
There's our 3, 0.
4, 1.
4, 1.
Yeah. 7, 2.
2. So here's 4, 5, 6, 7, 1, 2.
Okay, yeah. And 12. So it's 7, 8, 9, 10, 11, 12. 1, 2, 3. Good. And now Miss Boyd's going to draw her curve.
I sure am. Yes.
She's going to be good with curves because her lines are curvy anyway.
Oh, snap. She just dropped the mic on me.
So the domain obviously is all x such that x is greater than or equal to 3. And the range is all y such that y is greater than or equal to 0.
Got it.
That's domain and range.
That's easy.
So I'm thinking, Miss Boyd, example 2.
Right.
We should probably, what do you think?
We're gonna save for class, yeah.
Yep. And then Oh, you know, it's up to you. We would save this for class. Maybe we want to do, this is a different kind. This is a
Oh,
square root.
I thought you
I
said
didn't
to do it
realize.
on the
I
calculator.
apologize.
Okay.
No, we're actually,
'Cause it was
is that what it
one.
said?
Yeah,
Positive.
let's use
Oh,
calculator.
goodness. You know what?
So
You're
I
right.
figured let's just
Miss
save it for
Boyd
class.
is so right. She's always right. We're going to save this for class.
Okay.
Do you want to do this one or save this one for class 2? Should we just get this one done?
Yeah,
Let's get it done.
Get her done.
Yeah, get her done. So we're
All
going to
right,
create a table.
X
It's always nice to see one
square root
more.
of X
Plus
plus
one.
1. Gotta
Mhm.
extend that so Miss
Mhm.
Young doesn't go crazy.
I know.
And then f of x.
X comma.
Yeah, I forgot we were doing our
Did you
point.
do it backwards
Okay.
last time?
No, I think I
Okay.
did that. Okay. All right.
So let's start with, what do you think we're going to start with? -1.
Oh, yep.
Because I always start with the lowest X value I can
Yes,
use. What's
negative
going
1
to
plus
generate
1
0 under the
gives
radical?
me 0.
Mm-hmm.
So we got
Negative 1,
comma
0. Now, again, I'm not going to use 1.
No.
Not going to use 2, but I'm
No.
going to use 3 because 3 plus
Couldn't
1 is
we
4.
use 0?
Oh!
Would that be a nice one?
Oh my goodness.
Let's use 0.
What am I being so silly
Sorry.
for?
Because 0 plus 1
Yeah,
is
it's
1. Square root of
one.
1 is just 1.
Oh, Miss Boyd.
Let's use 0, comma 1. All right.
You're
now
so
which one?
smart. 3.
3. Yes, because square root of
3
3 plus 1 is 4,
Mhm.
and square root of that
4
is
is 2.
2.
So 3, 2.
All right.
And let's try 8. One more.
All right.
Because 8 plus 1 is,
That's right.
oh, yeah, 8 plus 1 is 9.
Square root of 8
Plus 1
is
is square root of 9, which is 3. So 8, 3. Let's plot these
All
lovely
right.
points.
So
Negative 1,
1,
0. 0, 1.
0, 1,
3, 2.
3,
No,
2.
you just did 2, 3. You did 2,
Oh,
2.
I did do 2.
Mhm,
Sorry,
mhm,
I thought I went over
mhm,
3. I apologize.
Over 3. You
I
still
keep
did 2.
Yeah, that's
There.
weird.
And over 8.
All right. 3,
4,
4,
5,
5,
6,
6, 7,
7,
8.
1, 2, 3. Yay!
All right.
Here's
Here comes my
our
squiggly line
curve.
because I'm used to it.
And you
Oh,
did drop it a little.
just-
It's not supposed to
I-
go below
just-
the
just
x-axis.
Just wait.
All right. So,
okay.
otherwise it would be wrong.
Yep. mhm.
Okay. The domain is all x such that x is greater than or equal to -1.
Yes. So here's our. Oh, let me get my pointer.
Mhm.
Here's my -1. So
Yep.
it's gotta go this way,
And it's
gotta go
above the
y.
x-axis. So y is
Alright.
greater than or equal to 0.
Great.
Oh, look at this. Oh, we love
Oh,
transformations.
We know how to do this.
This is a table. I'm not
Yeah,
even
so
going to
this
go.
up, down, left, right.
Yeah, I think
Stretch. All right.
I think we're good. Oh, can you do me a huge favor though
Sure.
right now?
Mhm.
Because we actually go, we don't do that. The
Oh.
horizontal ever. Mhm,
Oh yeah,
never,
we don't
ever.
do horizontal.
Mm-mm.
But I think our picture is covering the reflection.
Oh, dang it.
So can you?
It's in their notes though.
Oh, great.
Remember?
Yes,
They have
that's right.
notes. Just
So
this reflection.
it says reflection.
But
so
it's in your
remember, If we do
notes.
the negative on the outside, it's the y changes. If it's on the inside, the x changes. Okay.
Yep. And you
Great.
reflect across the x-axis versus y. That's why we wrote that extra note.
Mhm.
Ooh. So the graphs of radical functions can be transformed by using methods similar to what we
Right.
did with linear, quadratic,
Mhm.
polynomial, exponential functions.
Okay.
So this is all what we're used to, but Miss Boyd is going to do one thing.
Right.
She's going to cross off the 1 over b
Sure am.
because we're not going to ever
we
use.
don't do
Nope.
it.
So A is your stretch or compress, the absolute value of A.
Mhm.
Because remember, if there is a negative
Then
in
it
front of the
flips over
A,
the
it means it
x-axis.
reflects over the x-axis and your y is changing.
Right.
H is your horizontal translation and K is your vertical up or down.
Right.
So we have an example right here and we're going to
Okay.
do this. We're going to use the graph of f of x equals square root of x, remember that, our parent function, as a guide. We're going to describe the transformation and graph the function.
Great.
Look how easy this is.
I know it's on the outside, so I set up 5.
And we're done. And
oh
look.
my goodness. Yeah, because this was our original. We just move up 5.
That is
Done.
it.
That's easy.
All right, let's do the
Alright,
next one.
Sure. Well, again, it's on the outside, so up,
Up 1.
1.
And the
That's what
graph
we did.
shows it.
Bam.
Okay, let's look at B.
Mm.
Now there's not anything added to the outside, but there's a
No.
1/2 on the front
And that's compressed.
because it's less
Yes.
than 1. Compressed by 1/2.
1/2. And that's what they did. Whoop, they compressed it.
They
left it starting in the same
the
spot. so we didn't
vertex
go
is
up or
the
down.
same.
We just pushed it
And
down.
the
we
reason
compressed her
that's
trash.
right, and the reason that's the vertex is the same is we're not going up or down,
No.
left or right. We're just pressing it down like a garbage can.
Oh,
No.
it's all coming back.
Oh, here's a
Ooh,
good one.
All right.
So
So we have
the
this
negative in
tells
front
us to reflect
over
over
the
the
x-axis, and it does that in the picture.
X, well, whatever, x-axis.
Mhm.
And then that tells us not to go left, it's opposite. So we're going to go
Right
right forward.
4. Easy.
So we started here, we flipped it, and then
Mhm.
we moved it 4.
Correct. And B now, when the negative is under the radical,
Mhm.
which again, it's kind of like a horizontal compression, or not a horizontal compression, but it's like a horizontal compression stretch that we're not
Gotcha.
going to do, but we cover this briefly because the
Okay.
negative inside means you reflect over the y-axis. That's what that negative means.
Over y-axis.
And the +3,
Up 3.
yep. And the
So
graph
they
does,
flipped it from here
to
over,
there and up
then
3.
Up 3. Great.
and let's
These are
might
easy.
as well finish this.
Should we save one for class though, in case someone didn't watch
Oh.
the video? Just as a quick reminder.
Fine. And here we
Any video
go.
questions? You can do it. See you tomorrow.